So in this video, we're going to focus on the proof. The first question is, show by a counterexample that the following statements are not true in general. So to show a statement is not true, by using a counterexample, we need to give examples and show that the result is contradict to the statement. So the first question is, 2 to the power of n minus 1 is a prime number for all n belongs to natural number. So we can take n equals to 1, and n to the power of n minus 1 is equals to 2 to the power of 1 minus 1, and we get 2 minus 1 equals to 1, and 1 is not a prime number, so we can say that 2 to the power of n minus 1 is a prime number for all n belongs to natural number is wrong. The second question is, the sum of 4 consecutive positive integers is always divisible by 4. So we can take 1, 2, 3, 4, and 1 plus 2 plus 3 plus 4 equals to 10. And we can say that 10 is not divisible by 4. So this statement is also wrong. The third one is, m plus n squared is not equals to m squared plus n squared. So we can take m equals to n equals to 0. So 0 plus 0 squared equals to 0 squared plus 0 squared because they are all equals to 0. So on the question B, we need to use A and two similar properties to show that x squared plus y squared plus z squared is greater and equals to x times y plus y times x plus z times x for any x, y, z is the real number. So the first step is to multiply 2 in both sides. Then we can get 2x squared plus 2y squared plus 2z squared is greater and equals to 2 times x times y plus 2 times y times z plus 2 times z plus times x. Then we move all the right-hand side to the left-hand side. Then we get x squared minus 2 times x times y plus y squared plus x squared minus 2 times x times z plus z squared plus y squared minus 2 times y times z plus z squared is greater and equals to 0. We can rewrite the formula on the left-hand side to x minus y squared times x minus z squared times y minus z squared. And we know that x minus y squared and x minus z squared and y minus z squared is greater and equals to 0. So when x minus y squared times x minus z squared times y minus z squared is also greater and equals to 0. On the second question, question A, we need to prove that x squared plus y squared divided by 2 is greater and equals to x times y for any x and y is real number. So we can times 2 on both sides of the formula, and we get x squared plus y squared is greater and equals to x times y times 2. So we can minus 2 times x times y on both sides of the formula, and we get x squared minus 2 times x times y plus y squared is greater and equals to 0. So we can find that on the left-hand side, the formula can be written into the form of x minus y squared. And we know that for any number, the square of itself is always greater and equals to 0. So x minus y squared is always greater and equals to 0. So we can prove that x squared plus y squared divided by 2 is greater and equals to x times y.